Halogenation of which of the following will yields meta-substituted product with respect to the methyl group as major product, and the corresponding components given in the form of options for us for verification is given by. Here the corresponding options provided for us are: one is methyl is common over the benzene ring system, associated with aldehyde, associated with nitro, associated with hydroxy, the same thing associated with the nitro. The places are different. This is the meta, this is the ortho place, this is also ortho, this is also what? Meta position. Whereas this particular methyl is common and this methyl is acting as hyperconjugative group. That is plus hyperconjugative group, and it is acting as what? Activating group. This is acting as activating group, and it is a common species present at every part of the benzene ring system. Let us go for the other. This is aldehyde. Aldehyde is minus Me group and it is deactivating group. Similarly, nitro group is also, this is minus Me electron withdrawing group, and also this is acting as deactivating group. Whereas this particular nitro also position is different. This is also minus Me group and also acting as what? Deactivating group. Whereas this particular group is plus Me group, hence it is acting as what? Activating group. Whereas if these groups are deactivating, then deciding group in this case is methyl, deciding group in this case is methyl, deciding group in this case is also what? Methyl. Whereas as being this is plus Me, compare it to the hyperconjugative groups, this particular plus Me group will becomes what? Deciding group. If we go for the directing nature of the groups present over the benzene ring system, followed by the corresponding position related information. So these are the groups, whereas here the deciding group is activating group is methyl group is acting as ortho para directing group. So therefore this position will becomes ortho with respect to the methyl, and this position will becomes para with respect to the deciding group, that is methyl. In this case methyl is the deciding. Once again it is also ortho para directing group. One of the ortho place is blacked. So therefore remaining two places are the suitable places for the incoming electrophile to be getting substituted. Whereas this is the deciding group, ortho para directing group. One of the ortho position is blacked. So therefore this ortho followed by para position to OH is a single place, that is deciding. Whereas this is also ortho para directing group. These are two are ortho, and the adjacent opposite position is the para. So therefore these are the places where electrophile can be getting substituted. If electrophile is substituted, maybe this compound, maybe this compound, maybe this compound is produced, but these two relations are ortho relation, these two relations are para relations. Whereas with respect to methyl, this is ortho and this will becomes what? Para. With respect to methyl, this will becomes ortho and this will becomes what? Para place. Only this is the case with respect to the meta. With respect to the methyl, this place will becomes what? Meta is the place. And this particular compound is formed as major compound because strain will be little, it becomes most symmetric system. So therefore here this is the case where the electrophile, if it is getting substituted, electrophile takes either this place or this place. Electrophile either this place plus another one variety of the possible chances of substitution is like this. This is the place. This place is meta with respect to methyl. This place is also meta with respect to the methyl. So therefore the particular given four options consisting a particular option in this, that is this hydroxy and the methyl substituted over the benzene. If it is participated in electrophilic substitution reaction, the incoming electrophile is present meta position to that of methyl. With respect to the methyl, this will become meta place, this also becomes meta place. Next question is regarding annulenes, and it is a question like combination of assertions as well as the reasons. Let us go for the assertions as well as reasons. Yes, the assertions and the reasons, that is statement 1 and statement 2 provided for us are 6, 8, 10 annulenes are aromatic, non-aromatic as well as aromatic respectively. This is statement number 1. Whereas statement number 2 is planarity is one of the requirement of every aromatic compounds. Before going to the statements, let us go for 6-annuline. How 6-annuline is present? It is combination of 6 pi electrons in the cyclic system in a alternate system consisting of sigma and pi bonds. Whereas 10-annuline system, it is consisting of 10 pi electrons. 1, that is 2, 4, 6, 8 followed by what? 10 pi electron system is 10-annuline. Whereas 8-annuline we have to go for another system. This is 8-annuline system. This is 8-annuline. These are the annulines. Annulines are a special type of compounds in which cyclic nature is present associated with the alternative conjugations is said to be annuline. The total number of pi electrons on behalf of, if it is consisting 6 pi electrons, known as 6-annuline. If it is consisting of 10 pi electrons, 10-annuline. If it is consisting of 8 pi electrons, it is known as what? 8-annuline. As far the given information is concerned, they are claiming it as aromatic and they are claiming this 8-annuline as non-aromatic. Yes. Whereas the 10-annuline, once again they are claiming it as what? Aromatic. This is statement number 1. Whereas statement number 2 is planarity is one of the requirement to become a compound as aromatic compound. Yes, this is a compulsory statement. Without planarity, without cyclic nature, without planarity, we can't claim a particular compound as aromatic compound. To become aromatic, planarity is compulsory. So cyclic continuous conjugation of cyclic system associated with planarity followed by, if it is consisting 4n plus 2 number of mobile electrons, then only it is said to be aromatic. Hence statement 2 is correct. Let us cross check the validity of the statement number 1 as the 6-annuline is aromatic, 8-annuline is non-aromatic, followed by 10-annuline is also once again aromatic. Let us go for the 6-annuline. 6-annuline is cyclic consisting of conjugation. Moreover, here the planarity is present. Every particular carbon atom is of sp2 in hybridization, hence it is planar. Moreover, the total number of electrons are 6. 6 will becomes equal to 4 into 1 plus 2. Here this n is equal to 1. It also maintains all first, second, third conditions of Huckel are satisfied, hence it becomes what? Aromatic in nature. This is regarding statement number 1. Whereas statement number 1 consisting of another information, this is 8-annuline, they are claiming it as what? Non-aromatic. Yes, it is non-aromatic because what happens is, in case of 8-annuline system, due to having of 8 carbons, it doesn't present in one plane, it is associated with the tub in shape. So tub shape is not present in plane, hence here planarity is missing. If planarity is not present, these of all are said to be what? Non-aromatic in nature. Whereas the last case here, cyclicness, conjugation, 4n plus 2, all are satisfied because 10 electrons also becomes equal to 4n plus 2. But in this case, here these hydrogens, this hydrogen and this hydrogen are present very close to one another. Due to this very closeness, they felt very much repulsions. To avoid these unwanted repulsions, these hydrogens makes the cyclic system one part to move away from the plane, other part to move below from the regular planar system, hence it becomes non-planar. As being it is non-planar, it doesn't becomes aromatic, it will becomes what? Non-aromatic. But as for the statement 1 is concerned, it is claimed as aromatic, hence the statement 1 is what? Wrong statement. Statement 2 is correct and also appropriate statement, because it is also says regarding the aromatic nature, and the requirement for every aromatic compound to become aromatic, one of the necessary condition for the compound undergoing examination for aromatic is planarity should be maintained. Yes, it is correct, it is valid, it is true, it is appropriate statement, but statement 1 is wrong. This is the correct thorough explanation regarding the statement 1 and 2 present for these options.